Hi everyone, this is a Math 082 video. This is 3.6 special products. So there are two different special products that the book mentions. One is difference of squares and the other one is perfect square. So I want to go through both of them in parallel instead of in series so that you can see the differences and the similarities between them. Okay, so difference of squares is defined as a plus b times a minus b. Okay, so let's take a minute and distribute. So remember, we do FOIL. We do first, outer, inner, last. So let's take a minute and use our colors to go through this. So the first terms are a and a, so that results in a times a, or a squared. Then we do our outer terms, so that's a times negative b, or negative ab. Then we do our inner terms, which is a times b, or plus ab, and then we do our last terms, which is b times negative b, or negative b squared. Remember, at this stage, you always want to look for like terms. Do you see any like terms? I see like terms. Negative ab and positive ab are like terms. Also, when you combine them, they cancel out. So by definition, a plus b times a minus b is equal to a squared minus b squared. So one characteristic of difference of squares is that the result is that you have two terms. Okay? They are both terms are perfect squares. Okay? And they are separated by a negative sign. So the description is all in the name. Difference, remember, literally means subtraction. And squares is like a squared and b squared. So the difference of squares is describing exactly what you see here. A squared minus b squared is a difference of squares. And again, this is obtained by having the same terms in both sets of parentheses. And here I'll write this in a different color to bring attention to it. We have a and b, those are the same. What's different is that one of them is added and the other one is subtracted. And you should note, because of the commutative property of multiplication, it doesn't matter which one is first and which one is second. So let's look at an example that you might see of difference of squares. So let's look at 2y plus 3 times 2y minus 3. So already I can recognize that we have a difference of squares because when I look at these terms, the only difference is the change in the sign. As you go through, if you want, you can do the FOIL. You can do first, outer, inner, last. Okay? So if we do that, we would get 4y squared plus 6y minus 6y minus 9. And again, these inner terms will cancel out so that you end up with 4y squared minus 9. So the ultimate goal here is not to get better at FOIL. the ultimate goal is what we call pattern recognition. And this is going to become more critical in the next chapter, where you're given something that looks like this, and then you're asked to factor it. So you need to start recognizing difference of squares when you see them either in factored form or in this form right here. All right, let's look at this other example, which is the perfect square. So I want to go back here and just rewrite this a little bit more neatly. Okay, so again, remember, difference of squares is defined by a plus b times a minus b, and remember we showed ourselves that that means that's equal to a squared minus b squared. Okay, see if you can see the difference here between a perfect square and a difference of squares. So a perfect square is going to look like this. Okay, so take a minute, look at difference of squares, look at perfect squares, see if you can see the difference. Okay, so the difference, as you probably spotted, is that difference of squares are going to have opposite signs here. Okay, and then perfect squares are going to have the same sign. Now you might ask yourself, well, is it always going to be plus and plus? Okay, for the sake of convenience, we leave it plus, and remember b could be negative. So if we let b be any real number, positive or negative, then that takes into account the fact that we could be subtracting instead of adding. Okay, but again, the idea is that they're identical. They don't have opposite signs like we did in difference of squares. So let's take a minute and FOIL, just like we did last time, and see if the same thing happens. Let's find out if anything cancels out or if the middle terms are additive. Okay, so we have first, that's a squared. We have outer, that's plus ab. We have inner, that's also plus ab. Okay, and then we have plus b squared. Okay, so remember, at this point we look for like terms. Okay, unlike last time, the fact that we had opposite signs over here allowed for the middle terms to cancel out and disappear. Here, you might notice our middle terms, our middle terms are additive. So we have a squared plus 2ab plus b squared. So that is the definition. Okay, that is the formula for a perfect square. All right, so let's take a little bit more time and compare them. So over here, we said that this difference of squares, we said it results in two terms. Okay, over here, the perfect square results in three terms. Okay, not two terms. Okay, so again, we have two terms over here, difference of squares, a squared minus b squared. Over here, we have three terms. So let's just do a simple example that you might see in a textbook. So let's say I have 2 plus 3y times 2 plus 3y. Okay, so if you recognize this as a perfect square, then instead of foiling, you could literally just use this expression, right? So a is 2 in this example. and b is 3y. So my formula, remember, is a squared plus 2ab plus b squared. So I would have 2 squared plus 2 times 2 times 3y plus 3y quantity squared. Okay, and that would give me 4 plus 12y plus 9y squared. All right. Now the good news is that you don't necessarily have to memorize that, right? You can simply do FOIL here to expand that.